Hi everyone, welcome to Science Matters. And today's topic we have nature of force. Our learning targets for today are the following. After today's lesson, you are able to understand the nature of force, you can identify the different types of forces, you can discuss what is a net force, and draw a free body diagram. So let's begin. What is a force? Usually, we define force as a push or pull upon an object resulting from the object's interaction with another object. So therefore, force would only be present or exist if there is an interaction between two objects. But the question is, can we see force? Okay, the answer to that one is we cannot see forces, but we can see what it does and we can feel also the effects of different forces. So, what are the different effects of force? I have here an example, a player about to kick a ball. So, when he kicks that ball, the ball starts to move. So, what is the effect of force? Okay, the effect of force there is a force can make an object at rest to move. So the ball there was not moving from the very beginning, and as the player kicks the ball, it will start to move. So that is the effect of force. Next example. I have here a flying ball about to be hit by the player. So what is the effect of the force there? Okay, so the effect of the force there is that a force can change the direction of a moving object. So the ball is moving towards the player, and as the player hits the ball, it changes direction, right? Okay, so another example. Here we have a player catching a ball. The effect of force is, yes, it can stop a moving object. Okay, last example. I have here a lemon being squeezed. So what is the effect of force here? Okay, so we can say that force can also change. Yes, change the shape of an object. Okay, so these are the following effects of forces. It can make an object at rest to move. It can change the direction of a moving object. It can stop a moving object. And it can change the shape of an object. So now we know the different effects of force. Now, the next question is there any forces present on the following situations? Okay, here. I have here a Lamborghini being pushed by several people. So, is there any force present? Yes, there is. Okay, how about in this next example? Okay, is there any force present? Yes. Okay, last example. I have here Iron Man taking a break from saving the world. Is there any force present? Hmm. Okay. So before we can identify the different forces that are present, we have to know the different types of forces, right? Okay. So forces are divided into two types. We have the contact forces and non-contact forces. A contact force is any force that requires contact to occur. So we have the following example for contact force. We have applied force, normal force, frictional force, tension force, air resistance, and spring force. Let's get to know each one of them. Applied force. Applied force is the force due to the action of our muscles. Thus, we call it muscular force. So this happens when we push or pull something, we are applying applied force. Next, we have normal force. Normal force is the contact interaction between surfaces. It always acts perpendicular to the surface in contact. So I have here an example, a book sitting on top of the table. The book is exerting normal force against the surface of the table. Okay, so can you remember the example we have had earlier? Um, can you remember Iron Man sitting down? Okay, the force present there is normal force. Okay, let's proceed to frictional force. Frictional force comes from the interactions with the surface as an object moves or tries to move relative to the surface. So, every time we push or pull something, friction acts on the opposite direction. Okay. Next, we have tension force. This is an applied force where the force is applied through a string, cable, rope. Okay, like this one, there is tension force in this rope. Note that a tension force can only pull, it cannot push. We usually assume that the tension in a cable is the same everywhere or anywhere in the cable. Okay, air resistance force. This is the force that acts in a direction opposite motion through a gas. Okay? And last but not the least, we have spring force. Spring force is the force exerted by a compressed or a stretched spring upon any object that is attached to it. Non-contact force. A non-contact force is a force which acts on an object without coming physically contact with it. So examples of this are gravitational force, electrical, and magnetic force. Gravitational force of attraction or gravity. So this is the force that attracts any two objects that has mass. Okay? We all know what is gravity, right? Okay, let's proceed to electrical force. Electrical force is all about the attraction and repulsion of charges. So remember, opposite charges attract and the same charges would repel each other. Okay, I hope you have performed this experiment in school. We have here two balloons with the same charges, hence those two balloons will repel each other. Okay, it's because of the electrical force. And the last one for non-contact force, we have magnetic force. This is a non-contact force as it push or pull objects without touching them. So this is due to the magnetic field developed around the magnet. Okay, so now we have a summary of the following forces. For the contact forces, we have the air resistance, applied force, spring force, tension force, frictional force, and normal force. For the non-contact force, we have the gravitational force, the electrostatic force, and the magnetic force. So now we know the different types of forces. The next question is, how do we measure force? So we measure forces in newtons in honor of Sir Isaac Newton. Okay, we can write that as capital N. Okay, so we use a Newton meter to measure forces, or sometimes we call this a force meter. A force meter looks like this. I hope you have seen one. Okay? So, force meters contain a spring connected to a metal hook, and the spring stretches when the force is applied to the hook. The bigger the force applied, the longer the spring stretches, and the bigger the reading. So, we use here to measure the force. Okay? So, how do we represent force? Remember, we cannot see forces, right? So, now, how can we represent force? So we represent force by using a free body diagram. A free body diagram shows the forces acting on a certain object which can be shown by representing them as arrows. So how do we draw a free body diagram? Okay. So we use arrows to describe what different types of forces are present on the following situation. So I have here a book sitting on top of the table. Can you still remember the different types of forces? Can you identify what force is present? Okay. So, when we draw a free body diagram, we draw that object and the surface. No need to draw the whole table. Okay, we draw the surface and then the object, and then we label the different types of forces. So, we can draw the arrow down. Remember that one? What type of force is present? Um, Pulling that object towards the earth, we have gravitational force, correct? And what is the next force present? Remember, the book is exerting a force onto the surface of the table. Okay? So can you still remember what type of force is that? Yes, correct. That is a normal force. So when we draw the free body diagram for this one, we draw it as this. Okay? We draw the surface of the table, we draw the rectangle representing the book, and then the arrows depicting or showing what type of force is present. So the free body diagram for that example is this one. Okay, let's proceed. So here I have an example, a man pushing a box. So what is or how do we draw a free body diagram? So we do not need to draw the man. We only need to draw the surface and the box. Okay? And what is the first force that you can see there? Okay? So remember all objects are exerting a normal force against the surface. We have the normal force, okay, represented by an arrow upward. Next, okay, opposite of the normal force, we have, correct, gravitational force. And then as you can see, the man is pushing the box. It is being pushed towards the right. So that is applied force. It is using applied force. Remember, we call them muscular force. Okay? And aside from the applied force, there is one force present. Remember the other force that is acting opposite of the force being applied? Okay, correct. That is the friction. So this is how we draw the free body diagram for the following example. The box and the arrows would represent the different types of forces. Okay, so now you know how to draw a free body diagram. Let's proceed. So now we have here net force. Net force is defined as the sum of all forces acting on an object. So this is the sum of all forces acting on an object. We can solve net force as the following. F net is equals to the force number 1 plus force 2. Okay, so I have here an example. The book on top of the table. Let's calculate the net force acting on the book. Okay, so now we know it has normal force and gravitational force. So for the normal force, we have here 50 newtons, and for the gravitational force, we have 50 newtons. So when we calculate for the net force, what is the correct answer for that one? Or what is the net force um, acting on the table or acting on the book on top of the table? Can you solve that one? Please take note that the forces are acting on the opposite direction. Okay, so let's solve for the net force. So here we have the free body diagram of that book. And we have force number 1 going upwards is positive 50, and force downwards we have negative 50. Okay, because these forces are acting on the opposite direction. So when we add the two, we have 0 net force. Okay, so the net force acting on that table, and acting on that book on top of the table is 0. Hence, that book is not moving because it has 0 net force. Okay, let's proceed. So I have here an example or a problem. I hope you can solve this one. A box is being pushed by a man with a force of 100 newtons on the side, and a boy pushes the same box with 80 newtons on the same side. So the boy and the man is pushing the same box on the same side, but they have different forces. So draw the free body diagram and determine the net force. So, okay, let's draw. So we have here the box, and then we know that the man was pushing the box towards the right. Okay, applying 100 newtons. And the boy is also pushing the box towards the right with 80 newtons. So this is the free body diagram for that one. So now we proceed to calculating the net force. So what is the net force? We will identify the force number 1 as positive 100 newtons and the other one is 80 newtons. So the formula for that one is F1 plus F2. Now we have the net force for the box is 180 newtons. Okay, so that is how to draw the free body diagram and to determine the net force. So I hope you have learned so much today. Today we have learned and understand the nature of force. We cannot see forces, right? But we can see the effects of forces. And we also know the different types of forces. We have two, the contact and non-contact forces. And we now know what is a net force. A net force is the sum of all forces acting on an object, right? And lastly, now we know how to draw a free body diagram. So thank you for listening. See you on our next video.